So what happens when a web panel has more than one grid? In that case, it's not possible to consider the base table of the web panel, but rather that of each grid. The definition of navigations will depend on whether the grids are parallel or nested. Consider the case of parallel grids in the first place. Each grid will determine its own navigation independently from the other. So, it's possible that a base table exists for one grid and not for the other. In this example, both grids will have a base table because clearly you can see attributes in each of them. And that's enough to confirm that there will be an implicit navigation in each grid. And the question is, how do we determine the base table for each of them? Start by noting that this example differs from the previous one only in the fact that you've added the grid on the right and a variable to filter the data in that grid, and another one to show a total. It's a known fact that, in addition to the generic refresh event of the whole panel, when there's more than one grid, the generic load event disappears. Now you have a specific refresh event and load event for each grid. Each load event will be triggered only once or n times, depending on whether Genexus finds a base table for that grid or not. It's easy to infer that the base table of the first grid will be attraction, and the base table for the second grid will be country city. And in both cases, the filtering will be by country ID, an attribute received by parameter, which as usual, will not take part in the definition of base tables at all. It'll be part of what follows such definition. However, you could think that, since both tables are related in the database, note that, in fact, country city is part of the extended table of attraction, so for each attraction loaded on this grid, there will be an associated record in this table. Or, considering it the other way around, for each city loaded in this other one, there will be n related attractions. As mentioned, you could think that this relation will have an effect on what's loaded into the grids, but it will actually not. Genexus will not define any implied relation between them. All the attractions in the country received by parameter will be loaded in the first grid, and all the cities in that country will be loaded in the second grid. With this possible confusion now cleared, focus now on how Genexus defines the base table for each grid. Take the first one in line. Consider the grid's attributes, visible or hidden, the same grid properties as for the case of a single grid, the base transaction, obviously, and properties, order, conditions, unique, and data selector. Unlike in previous cases, the separate attributes of all events will not be considered here. Only the load event of the grid will be. So, in the case that a separate attribute existed in the refresh event, it would not be participating. In addition, for the case of the first grid, and only for the first grid, if attributes exist in the fixed part, as is the case, these attributes will also be considered for determining the base table, and only for it. In the case of all the other grids, none of the attributes of the fixed part will participate. So in our case, in determining the base table of grid 1, all these grid attributes are considered, in addition to any others separated in this load event. There isn't any. And of course, the grid properties mentioned. It's clear why there will be a base table, which will be attraction. If any of these attributes were not in attraction's extended table, then we would be warned in the navigation list. Additionally, in order to determine the base table of grid 2, the ones considered will be all these grid attributes, and any others separated in the load. In this case, there isn't any either. Also, the grid's properties will be considered. We can clearly see why the base table is country city. In this case, the country name attribute of the fixed part doesn't participate. But what happens with the attributes that appear in these other events? They must just belong to the extended table of any of the grid base tables. Otherwise, we will be informed in the navigation list. In this case, we have country name and attraction ID. Like we said, for parallel grids, navigations are not related automatically. If, for example, when the user clicks on a line of the grid that shows cities, we wanted the grid that shows tourist attractions to only show those in that city, as we can see here. How could we do this? There are several ways to go about it. We'll show the one implemented here. Following a save of our panel, we set the Allow Selection property for the city's grid to allow the selection of a line through a click on any part of it. We can make it appear with a different color or not. We also program the grid's online activate event for a line to be triggered when the user selects it, with the possibility of assigning the city identifier of the line selected to a variable. Then, we refresh the attractions grid because we added a new condition, that only the attractions whose city matches that of the city ID variable be loaded, to the extent that the latter is not empty. This will achieve the behavior shown in runtime. The other option is to directly show the attractions for each city in the country received by parameter. This means using nested grids like we did here. We're all well aware that having nested grids is similar to having nested for eaches. So, the way to define their base tables and resulting navigations will be analogous. If you program this object as listed, you would have the external for each navigating the country city table, which will have an implied filter by country ID. So, it'll go over all the cities in that country, and for each of them, it'll print its name, and prior to moving on the next one, it'll execute the internal for each, which will go over the attraction table, filtering implicitly by country and city, and printing each attraction in that country and city. This is the navigation that you'll achieve in your web panel. But, like always, there are two options: implementing each grid with or without a base table. When you implement both grids with base table, which is the way to work less, you'll be establishing the country.city base transaction for the first grid and attraction for the second one. For any case, the refresh event of grid 1, the external one, will take place first, followed by that grid's load event n once or n times, depending on whether the grid has its base table or not. In this case, since two cities, Paris and Nice, have been entered for France, you know that the external grid's first load will be Paris, and immediately after, and prior to executing the load again to load Nice, the refresh event of the nested grid will take place. And its load event will come immediately after, once or n times, depending on whether it has base table or not. It does have base table in this case, so a load will be triggered to load the Eiffel Tower and another one to load the Louvre Museum. Once the load of the nested grid is concluded, it'll move on to load the following city, Nice, and it'll be the same, triggering the refresh event of the nested grid once to then trigger the load event n times for loading the new attractions in Nice, which in this example is just one. Here, the variables are added to the screen to complete the rest you had previously. This will make the example identical, with the need for programming all the events in the system. Translating this into a Genexus pseudocode would result in something like this. First, the external grid's refresh is executed. There, we set to 0 the variable that will count the total number of attractions that will be loaded. Then, And because this is the case of a grid with the country-city base table, Genexus will establish the implicit for each that'll navigate this base table, filtering by the value of country ID received by parameter. For each record found, that grid's load event will be executed. It'll have that city's attractions, which it will add to the variable that will be totalized. Then, the city is loaded on the grid from the load command that Genexus includes. Immediately after, the refresh of the nested grid is executed, leaving in 0 the value of the total sum of trips that include that attractions that are loaded afterwards. And because it has base table, Genexus writes another implicit for each to navigate that base table, attraction, to which it adds all the corresponding clauses, according to what the developer made explicit in the grid's properties. In this case, you had only established base transaction and order clause. Additionally, it adds the implicit conditions that precisely relate to the fact that this grid is nested with another one, and a relation between the table exists. For this reason, it'll only go through the records of the attractions table that match the country and city of the record loaded in the external for each. And for each of them, it'll execute the load of this nested grid. And then it'll load the line on the grid. Of course, if the first grid had no base table, then the implicit for each disappears, as well as the load command. And we'll have to explicitly write them in the grid's load event. In this case, upon finding the load command inside the grid's load event, because the grids are nested, Genexus will immediately trigger the refresh and load events of the nested grid. And, depending again on whether the nested grid has base table or not, Genexus will either establish an implicit for each and its load or not. Except in this case, you'll have to make explicit the where of cities, which was implicit before, as we'll see next. If you wanted that the nested grid not have a base table, it's clear that you would substitute attributes by variables in the grid, and you'll have to program the for each explicitly in the load event, as well as in the load command. And precisely because there are not base tables, leaving the logic for loading grids fully up to the developer, Genexus may not establish the automatic join between the for eaches. And for this reason, you'll need to make the filters explicit. You will establish only the filter by city name, because the filter by country ID will be carried out due to the parameter. Here, it's implemented in Genexus. If you take a look at its navigation list, you can clearly see that it did not select base table for any of the two grids. And if you execute, you won't see any difference with the web panel that had base tables for both grids. But to reach these navigations, you had to determine the base tables in the first place, just as it occurs with the for eaches. In order to determine the base table of the first grid on screen, the exact same thing that you saw for parallel grids will apply. That is to say that Genexus takes into account the attributes of the grid itself, plus those corresponding to the fixed part of the screen, in addition, of course, to any that may appear in the grid's properties, base, transaction, order, and so on, and those of the load event for the grid, but neither those of the refresh of the grid nor those of any other event. When a base transaction has been specified, it'll have that base table, and all the attributes mentioned will have to belong to its extended table. If no base transaction has been specified, then Genexus will find the minimum extended table containing all the attributes mentioned, and it will then select its base table as the grid's base table. The base table of the nested grid is determined as if the grid were parallel and not nested, except that it'll be the same as for determining the base table of a nested for each. When the nested grid has no base transaction specified, then Genexus will determine it on its own. And here's where the fact that this grid is nested with another one may determine a table different from the one that would be determined if the grid were parallel. These cases are not frequent, but it's good to be aware of them. For instance, if the grids were inverted, and the external grid navigated the attraction table with no base transaction specified in the internal grid, with only the city name attribute implied, and the grid being parallel, then it's clear that Genexus would determine the city's table as its base table. However, in this case, and because it's nested with a grid that has an extended table that includes the attributes of the second grid, it'll select for this second grid the same base table as that of the first grid, thus implementing a controlled break. And this concludes the study of determining base tables and navigations for all cases of web panels.